So I just finished discussing about key points of our parent functions. Now I want to explain how that works. So what you're doing every time you have some transformations is you're going to start off by knowing what should happen to this function and then using those transformations to kind of let you know what is going to happen after it's been transformed. So let's look at this function. Y is equal to negative x plus 2 quantity squared plus 1. So we know what the parent function of this is, or you should by now. It's going to be, let's call this actually, we can call this f of x, and we'll call the parent function g of x. So g of x is going to be equal to x squared. And what we know about x squared is it goes to the points 0, 0, 1, 1, negative 1, negative 1. You can also go further from there. You can go 2, 4, and negative 2, negative, or negative 2, positive 4. So here's our parabola, g of x equals x squared. Here's g of x. So we expect a parabola to go through these points if it hasn't had any transformations on it. But these other stuff, all this fluff in here tells us something's going on. So what's the other stuff? It's this negative out in front here, it's this plus 2 inside of here, and this plus 1 right there. So let's go ahead and break that down into transformations. So the way I like to order transformations is you apply them as you would simplify plugging in a value for x. But, so that's how I'm going to do it today. But there is an exception to that rule. If there is anything in front of this x that we need to factor out, then the exception would be you always shift last in those cases. If there's a coefficient in front of x, you have to factor it out first before doing any transformations, and you have to shift last. So this doesn't, we don't have anything there, so we can just go ahead and follow my standard, which is plug in a value in your head for x and then see what simplifies first. So if I plugged in, let's say 0, first thing I do is add 2 to it. This add 2, that's a transformation. So we're going to list our transformations. And this add 2 is going to be a horizontal shift because it's happening to the x. It's happening on the input of this quadratic. So it's going to be a shift 2 units. Anything that happens on the input is actually counterintuitive. It's the opposite of what we think. So instead of adding 2 meaning plus 2 moving it to the right is what we usually think when we add 2, we're actually moving it to the left. So shift 2 units to the left. After I would add 2, then I would square it. That's not a change, it's not a transformation, so don't worry about writing anything down for that. Then I would apply this negative to it. So this negative is going to be a reflection. So we're going to reflect across, well, think about it this way, this negative is happening to, it's not happening directly to the x, which means it must be happening to the y's. If that was happening to the x, it'd have to be right there in front of it, but it's not. It happens after we've done all this stuff, so it's happening outside of the input, which means it's happening to the y's, which means we're taking positive y's, the stuff above the x-axis, and moving it down, and negative y's and moving them up, so reflecting across this x-axis. The last transformation is this plus 1 on the end here, and that is, again, it's not happening directly to the x. We're not adding 1 to the x. We're adding it after we've actually processed it through the parent function. So it's happening to the y's. So this is going to be a shift again, 1 unit, but in this case, it's going to be what, up or down? Well, it's going to be up. It's just exactly what you think it is. If it's happening to the y's, it's only counterintuitive if it's happening inside there, happening to the x's. So how do I apply this to my key points? Some people like to actually make up a table of values, but I really discourage that because I think then that you're not kind of internalizing the big feeling, the greater feeling of what's happening to all these. So let's go ahead and graph our parent function on a graph, which is 0, 0, 1, 1. I am being really lazy right now about graphing or scaling my axes and labeling them, but you guys should not be because you're getting graded for it. So here is g of x, and I'm going to label it. That's my parent function. Let's start with my anchor point. What happens to my anchor point or my vertex of this parabola after I shift 2 units left? Well, that means that I end up going right there. So now my vertex is here. I'm going to try and do this lightly, even though it's in pen. I'm going to try and sketch it in kind of lightly. So 2 units to the left, I reflect across the x-axis. Well, this is my x-axis, which means everything is going to get flipped over. So I'm going to end up with a parabola going down, but I'm also going to shift it up. So I'm going to end up here, going down like that. I don't have any stretching or compressing. So here's the point. I moved my anchor point over here after all the I know where the reflection is going to be, and I shifted. So what do I go from here? If I don't want to plug in a table of values, what happens? Usually I go right one, up one, left one, up one. But this time I'm reflecting across the x-axis. I know I have to go down. So I'm going to go right one, down one, left one, down one. Now notice that these 1 and 1, that just gives me directions. That doesn't give me a point. This is not the point 1, 1, obviously. This is where we mapped to. This is where this point ended up after the transformations. This is where this point ended up after the transformations. Let's do the same thing for 2, 4, and negative 2, 4. So we usually go, from the anchor point, we usually go right 2, up 4, left 2, up 4. We're still going to go 4 and 2, but we're not going to go in the same direction. When I move right 2, because of the reflection across the x-axis, I'm going to go down 4. So from this anchor point right here, I'm going to go right 2, oopsies, yep, right 2, down 1, 2, 3, 4. So this point right here mapped to this point right here, and I drew a triangle upside down on purpose because it kind of helps you orient what just happened. And then this point right here, let's go ahead and put a little star over it, is going to get mapped by going left 2 and then down 2, 1, 2, 3, 4. So we end up right there. And we can go ahead and sketch in our second parabola right here, and that's going to be f of x. So the idea is that you have an anchor point that gets shifted, and then you use your reflections and your stretches to determine what comes next. But really you're using your original instructions. My instructions for a parabola is right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. You're going to use those instructions and you're going to make the changes you need to. In this case, it was just a reflection from your anchor point to determine where you end up. And from here, I could determine what those coordinates are. But I didn't actually plug in any values to do that. If you had any, last thing is if you had anything that was a vertical transfer, or like not a vertical, just any kind of stretching or compressing, that would happen to your directions going down in this case. So if, let's say, I did have a, let's say, a stretch vertically by a factor of 2, instead of going right 1, up 1, I'd go right 1, down 1, 2, because I'd have the reflection and the stretch by a factor of 2. So my y's would be vertically stretched by a factor of 2. So my y instructions, instead of going right 1, up 1, I go right 1, down 1, 2. And I'd go right 2, down 1, 2, 3, 4, 5, 6, 7, 8. All of my y's are going to get multiplied by 2 if I vertically stretch by a factor of 2. So again, I'm not plugging in a table of values. I'm using my parent function as a set of instructions, and I'm using the transformations that I can pull from the equation to make changes to those instructions to graph the correct graph. And that's it.